Hi everybody, it's me Adarsh Khadka, and in this video we will be discussing about cell sort, which is one of the sorting algorithms used to sort unsorted group of data or array in a systematic way, either ascending or descending order. So what is cell sort? Cell sort is an advanced version of insertion sort. It improves the performance by allowing comparison and exchanges of elements that are far apart rather than adjacent elements. It is named after Donald Shell, who introduced this algorithm in 1959. Why is it effective? It is effective as it sorts distant elements first, then the algorithm reduces the total number of movements required during the final phase, which is when the gap is reduced to 1. Now let's discuss about the working of cell sort. Cell sort starts by sorting elements that are far apart and progressively reduces the gap between compared elements. Now let's begin with the steps. At first, start with a large gap, the interval of between the elements being compared. Compare the elements that are gap distance apart. Suppose the gap is 4, then elements that are 4 spaces distant are compared and are swapped after comparison. Perform a modified insertion sort where the elements are compared and swapped if necessary, as I said before. Then reduce the gap, typically half, and repeat the process. We continue this process until the gap is 1 and a final insertion sort is performed to finalize the order. Now let's look at the visual representation of the cell sort algorithm. As we can see that we have been given an unsorted array of size 7 having index 0 to 6. First we calculate the gap, that is by adding the index of first element and last element, that is 0 plus 6 by 2, which gives us 3, and then elements that are 3 places apart from each other are compared. In this case we can see that 10 is compared with 50, 1 with 4, 23 with 9, and minus 4 is as remain alone. Then again we can see that after arrangement or sorting of arrays, or after certain comparisons, we can see that 23 and 9 are not in order after comparison, so they are replaced with each other. Again minus 4 is compared with 50, as they are 3 places apart and are not in sorted form, so they are again replaced. Hence minus 4 after sorting reaches at the first index. Then in the second pass or the second iteration, gap is once again divided by half using floor division. After using floor division, we obtain gap value 1, as the previous gap was 3, which is divided by half, we obtain 1.5, but after floor division we obtain 1. Then all the elements are compared with each other, and finally we obtain our sorted array, that is minus 4 is placed in the first index, 1, 4, 9, 23 and 50. The array is sorted in an ascending order. Now let's discuss about the efficiency analysis. In this algorithm, insertion sort is applied in large interval of elements and then interval reduces in a sequence. Therefore, the running time of cell sort is heavily dependent on the gap sequence it uses. So the worst case time complexity for cell sort is big O of n square. Average case time complexity actually depends on the
gap sequence that we have used, and the base time complexity is n log n, big O of n log n. Now let's look at the advantages. First advantage is simple implementation. It is easy to understand and implement. Second advantage is that it is efficient for medium-sized lists. It is better than traditional insertion sort for lists that are moderately large. Third advantage is that it is in place sorting. It doesn't require extra space. And fourth, improves insertion sort. It reduces the number of comparisons by enabling comparisons at greater distances. Then let's see some of the disadvantages. The first disadvantage is that it is not optimal. There are more efficient algorithms like merge sort or quick sort that outperform cell sort in many cases. The performance is heavily dependent on gap sequence, which means the gap sequence choice is critical to performance. Poor choices can make it slow. And last but not the least disadvantage is that its unpredictable behavior. Its performance can vary widely depending on the gap sequence used.
And finally, on the last slide, we will be discussing about when to use cell sort. Cell sort is used when space is a concern and you need an in-place algorithm. Also used when the data set is not very large and you need something faster than insertion sort. And finally, a simple low overhead sorting method is needed in a system with limited resources.
Now let's look into a cell sort program written in VS Code. Firstly, we have defined a cell sort function and have passed array into the function. Then we calculate gap using length of array and dividing it by 2 using floor division. Then while the gap is greater than 0, a for loop is initialized. Then j is initialized as I. Then j is compared with gap, and all the elements at gap values are also compared and rearranged. Then the value of j is reduced, and finally the value of gap is again halved using floor division. Now let's look into an example. Here we have taken an array having 7 elements which is unsorted. Then after using cell sort function, the array is rearranged and the obtained output is, after using cell sort, is here. It is arranged in ascending order: 11, 12, 22, 25, 34, 36, 90, which is the required ascending order. Thank you very much.